Hello, hello. Welcome everyone to another day of daily LeetCode live streams where we do a ton of LeetCode questions in hopes that we can get better and better every single day. We make progress towards our milestones and hopefully land that job or just hone in on your engineering skills. A little bit of a longer intro today was just actually sorting some things out, so needed to just take some extra time in the beginning. But let's go ahead and do a quick recap as to where we left off yesterday. We only did a single question yesterday. I had to take care of a personal matter. So the question that we did yesterday was merge two sorted lists. It is up on my website now, which we should check it out, right? So merge two sorted lists. You can find it right here. You can find the stream clip, the question itself, the different topics it goes over. So some good practice for everyone looking to get that practice in. Without further ado, let's go ahead and start off with our next question today. The first one being binary number with alternating bits. So given a positive integer, check whether it has alternating bits, namely if two adjacent bits will always have different values. Okay, so one thing I think of is really I just want to check instead of seeing if they're toggled, and you know what, there might be, I just realized something. There's a way that we can probably make this very easy, right? If I were to, let's imagine we have like 101, 1010 versus like 1011. I'm trying to think here what the difference would be. I'm trying to see if there's a way that we can do this in a way that we can just create like a simple mask. It'd be nice if there was like some operation that I said if I did some bitwise operation against some mask, I would just get 0, because this is sort of an interesting pattern here, right? Almost like if we had 0101, that'd be pretty cool. Now, is there always a correlation between ones that are like if I AND this with 7, that's not really gonna do. Oh, actually, wait, this is 6, so I should do 5, right? So that's gonna be this one. If I have 7, what if I have, what other ones are 5, 7, false? What's like 101? That's the one I just did, right? So let's do 010. That's 1, 2, and 4. That's 5. If I do it with 4, what do we get? 0100. Okay, so that's not really like a pattern there. I mean, one thing that we could do is we can just go through the entire binary representation of this number, and we'll always check like consecutive numbers and make sure they're not the same. But I just know there's going to be an easier way to do this. Check whether it has alternating bits. If I continue shifting it to the right, and we only want to do it up until, check whether it has alternating bits, namely if two adjacent bits will always have different values. So this is another one of those cases where I want to find the last significant bit, or the last bit that's set. Because if I continue going, like let's say I do something like this, if I go through this whole binary string, I'll see these two zeros next to each other and I might return false, right? So if I'm doing 5, I only want to check 101 and nothing else to its left. Give me a second, gonna have a sip of water. Drink your water, everyone. If you haven't drank water today, drink your water. One zero one 010. Isn't there a way that we can actually, let me see something. If I do the not value, so I have this like crazy keyboard that I have no idea how to do the escape, like how to toggle the tilde. There's no easy way, so I'm gonna have to look up the tilde here. Actually, will that even work? That might not work. Wow, not 5. Let me see. Bitwise operator. Flip all bits. Is this cheating if we look at this? Unary operator is bitwise negation. Okay. How do you flip all bits? That's what I would like to do. But I also wonder 2, 5. It also doesn't just do, let me see, bitwise negation. The unit operator is bitwise negation. If you need fewer bits, then you'll need to mask it with and after the fact. Simply use the bitwise not operator. To use the k least significant bits, convert it to the right mask. As suggested, one can create the mask as 1 k minus 1 instead of using a loop. Flip bits 2. Now what is k though? Just give me the expected value, 26. Okay, I think what we need to do is maybe we just need to, this is n mask, return n, simply use the bitwise to use the k least significant bits, convert it to the right mask. I assume you want at least 1 bit, of course. That's why the mask starts at 1. The negation and the mask. I see. So if I had a mask of mask or equals mask 1, I'm very curious about something. If we did the negation of 5 or 7, well, that's -1. Yeah, it's something that we've come up with a lot before. Like, how do we... Okay, let's figure this out. So we're going to get the position first. What I'm going to try and do is, we know the binary representation of 5 is this, 1, 0, 1. So I want to create a mask that's just up until the position of the last set bit. So to do that, the way that I've done it before is get position of number. We'll just do num. And let's say let position equals 0 while num position plus plus num equals num right of 1 return position. So if just here we do console log, or actually let's just do const position equals get position of n console.log position. So I just want to see for that first one, which is 5, hopefully we should get 3. Okay, 3, so that's good. Now I guess it's saying that we want to return, I know it's sort of, it really is cheating, but return n and a mask. So we already have our mask created. Int k least significant bits. Is this, I guess this is the answer here. It's not, yeah, I feel like we didn't really, I feel like I had the pieces in my head. It's just mostly like a syntax thing. Like now if I want to create this mask, something like create mask given a position, and say let mask equals 1 for let I equals 0, I less than position, I plus plus. We can say mask equals mask to the left or 1, and then we'll return mask. Oh, return mask. So let's say here, let's say our mask is create mask given our position. So it'd be nice if our mask, let's actually start it off as 0. We should now get 7. Okay. So am I just to think that we should do this operator, like return this n and mask? Well, that's true and true. And is that true because the binary representation of 7 is 1, 1, 1? That's interesting though, because how is that? Because if it was 1, 0, 1 and we mask it with 0, 1, 0, wouldn't that be 0, 0, 0? So shouldn't this actually be false? Am I true, false, true, true, false, false? Okay. Maybe we should do the not of n and mask equals 0. Let's try this out. False, true, false, true, false, false. Let's think about this, right? We have, let's see what we're doing here as we go along. We have a 5, which is 101, and actually we don't even need this. So n equals 101. The position is 3, so we come to create mask, and we create a mask of 111. Now let me think about this. If we flip every single bit, we're going to end up with some long number. That's going to be like 111111000. And if we mask all this, with, right, if anything, we shouldn't really, oh yeah, if we just mask this with 1, then it should be 0. Now, should it be, yeah, that makes sense to me. 0, 1, 0, right? The n, not n, should give us 0, 1, 0. And mask. So if we did, so we have again some large number like this, 0, 1, 0. These are the last 3 at the end that we care about. And then we mask that. Maybe what we should do instead is 0, 1, 0. These will all be 1s though. Yeah, these will all be 1s. And then we AND that with mask, which will be this. Yeah, so that actually doesn't even work. What is it that we want to do? If we do, what if instead of even doing this mask first, maybe it's something with the ordering of which I'm doing this operations down here. What if instead we did, so let's come back to the drawing board, and actually maybe I should pull up Excalidraw here. Excalidraw. Apologies for like the political edge. Like, you know, we get the edge screen there. So if we do like, right, this is what 5 is, and then we have something else. If we get the negation of this, it's going to give us something like this. Well, this is not a 1-for-1, but imagine that 0, 1, 0. Oh, Jamin19. Hey, thanks for subscribing, Jamin. Welcome to the party. Hope you're having a good time. So imagine we have a negation here. What are we going to get from this if I AND all this? Actually, wait, we're just going to get n and not n. Wait a second. Can we just do like end and not n? Right? Because if this is the negation and we AND it, we will get 0, right? Did I just overthink this? Let me see. Oh, it doesn't like this thing that I drew here. Probably not going to like this. And if that's the case, true, 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 okay. Not n and n equals 0. Would that not work either? Yeah, party time. Hand sanitizer. Good to see you again, man. I know that we're very close, and I feel like presumably 1 or presumably 5 is written like this, right? We have a ton of leading zeros followed by 1, 0, 1. And if I negate that whole thing, we'll have a ton of 1s followed by 0, 1, 0. And now if I AND this whole thing together, I should get 0. I wonder if maybe I'm doing something wrong though. Negative n and n equals to 0. I know we're so close. I know we're close. I know we're close. Why wouldn't that work? I mean, I guess we just saw the results of that, right? If we do, oh, wait. 5 and, let me copy the tilde. 5 and not 5 is 0. Oh, but wait, that doesn't tell me. Okay, that's dumb. That doesn't actually tell me if, yeah, because all these will always be 0 because it's just going to be the opposite of whatever. The opposite of whatever it is. Like if it's 7, we have 7. And I got the negation of this, 0, 0, 0. It'd be nice if these were like next to each other. Yeah, that's going to give us the same answer, but this is not going to be, 1, 0, 1. Unless we do just have to count. This one's a little bit tricky, but I know we're close. And I know I've also said that a couple times, but maybe spend another couple of minutes, maybe like 1 or 2 more minutes, and then we'll get to the next one. That way we're not spending too much time on a single question. If 2 adjacent bits will always have different values. Because like the one thing in my head, right, is just going through everything. Like we already know the position of the last set bit. So I can start from the 0th bit and go all the way down and just make sure that there are no 2 bits that are ever next, like the same, that are next to each other. So like we can get whether the first bit is on, and then we go to the second one. If it's not the previous one, that's fine. We update it to the current one. We go to the next one. If it's not equal to the previous one, that's fine. We could do something like that, although I know there's some better way of doing it. But maybe let's try that. Let's try that out. We have our position. We have our position, which is 3. That's how long our loop needs to go for. So let's do something like for let I equals 0, I less than or equal to get position of n, I plus plus. Okay. And I shouldn't put a method in here because that's probably going to be called every single time, right? Const position equals get position of n. And let's just do position inside of here. Let me remove all this. And I think probably what we should do is not even start a position. We should start at this one. And we can say let previous equals, let's see, we want to get the first one, right? I want to get whether it's on or off. If I AND it with 1 and it's on, if it's off, okay, so we can say previous is n and 1. So just to make sure I'm doing this right, if we take 5 and 1, okay, if we take, let's see, 4 and 1, that should be 0. Fine, okay, cool. So starting out 1, what do we want to do? We want to get the current bit if it's not opposite the previous, or rather if it's equal to previous, return false, else set previous to current. So what can we do? we can say let current, and I'll set this equal to const current bit is equal to end, and let's see, a couple things we want to do. I need to get that mask. I need to set a mask. Let's do mask equals 1. I can say mask I and mask I if it's equal to previous. If previous current bit equals previous, return false. And then we'll say previous equals current bit. Let me remove these. Let's return true down here. And let me clean up a little bit here. Instead of doing my mask here, let's see, const get position. We have our position. Let me go ahead and create my mask. So n and mask. Here we have for let I equals 1, I less than or equal to position, I plus plus. We get the current bit by doing n and mask to the left of 1. So I'll get the second bit. Current bit equal to previous, we return false, else previous equals current bit, and we continue going. So let's see what this gives us here. True, true, true again. Let's think about this. Let's think about this. Current bit is n. So if we have a 101, we have 101 and our mask looks like this. So mask is 1, previous is end and mask. Okay. Previous is end and mask, which should just be 1. For let I equals 1, I less than or equal to position, I plus plus. Const current bit is n and mask to the left I, so we shift it over, right? So we should essentially be left with this now. This is going to be 0. If current is equal to previous, which is not, return false. Okay, previous equals current. Now the previous is 0. Then we go to the next one. Current bit is n and mask I. Okay, now we shift it over twice. If 0 equals previous, which it does not, return false. Previous equals current bit, I plus or equals. So maybe, oh, I think maybe it's this one here. What is happening here? This is so annoying getting these like X's here. I feel like that should have been right. If we have 0, 0, 1, well, okay, 1, that's fine. If I have 1, right, that's 2, that's 4, okay, all looks good so far, right? Because that's going to be our mask. Pushed to the left by the value of I. I is less than position, which we get up here. Current bit, so like 1, 5 and 1 is 1. 5 and 2 is 0. 5 and 4. Okay, so it's not that I need to get, yeah, this is always, how can we just get the value of like 0 or 1? I guess we can say const current bit, let's see, and if this equals 0, we set it to 0, else 1. We could do that. Let's see what this does. I'm doing this to like normalize any and value to 0 or 1. Now we get false, false, false. And mask to the left of 1 if that equals to 0. This is like all over the place. Sometimes questions are easy and other ones, even though they seem easy, are a little bit more difficult. But I feel like I'm so close and I don't want to move forward. Let's see, n mask equals 0. Then we'll set it to 0 or just make it 1, right? Because we already figured out that if we do 5 and 1, okay, 5 and 2, we're just going to set that equal to 0, 5 and 4. All right, if we do 7 and 1, yeah, so the first one will either be 7 or 0, const position, console.log current bit and previous. Really want to see what this is. 1 1 1 1 1 1. Is it maybe some like weird order of operations here? I mean, let's see, current bit equals 0. I feel like that's the same thing, but let me see if this changes anything. If it does, it might be because some ordering that I have going on there. True, false, false, true, false, false. Okay, that was a little bit better. True, false, false, true, false, false. Let's run this and see what happens. 15.92. Okay. I mean, we got the answer, and I guess it's a little bit cool how we did it, even though it's not anything that we shouldn't know how to do by now. But we probably should learn how to do this quickly. I promise you, I feel like it's a one-liner. It probably is. Okay, convert to string. No. Divide by 2. We can get the last bit and the rest of the bits via n modulo 2 and n divided by 2 operations. Let's remember current. The last bit of n, if the last bit ever equals the last bit of the remaining, then 2 adjacent bits have the same value, and the answer is false. Return n and n. Check if 1 plus n is the power of 2. Okay. You guessed wrong, I mean. Joshua's idea is cool, but I believe mine is even a bit more efficient. No need for all. No need for the last bit shift. I really want to... We know that if we shift the number by 1 to the right, all the 1s will become 0s and vice versa. Now if we AND those two numbers, we can get the whole thing as 0, but that won't work for numbers like 2, 4, 8, so we'll take another approach. Instead of AND, we'll do an XOR. This will make all bits 1. Now we need to check if all the bits are 1. The best way to do that is AND the number by number plus 1. It'll give you 0. Oh, interesting. Now if we AND these numbers, we can get the whole thing as 0, but that won't work for numbers like 2, 4, 8, so we'll take another approach. Instead of the AND, we'll do an XOR. This will make all bits 1. Now we need to check if all the bits are 1. The best way to do that is AND the number. It'll give you 0. AND and n plus 1. N equals AND or. Interesting. That's actually very neat. Because if we do 1, 0, 1, 0, 1, we shift it over by 1. If we AND that, we will get all zeros, but it doesn't work for numbers like 2, 4, 8 or powers of 2. So we instead shift, we still do the right shift by 1, but now we XOR it, we get all 1s. N plus 1 turns all those to 0 and leaves us with 1 here. And n plus 1. So and n plus 1 will just give us 0. Amazing, thank you. That's very cool. This one I really do appreciate. I appreciate this answer. Well written, and I understand it. So that's pretty neat. Let's get to our next question, because there's actually some other questions here I really wanted to get to that I think are good. Like missing numbers, pretty cool. All right, so given an array nums containing n distinct numbers in the range of 0 through n, return the only number in the range that is missing from the array. Yeah, so can you implement a solution using only O of 1 extra space complexity and O of n runtime complexity? Really the way of doing this is, since we know all the numbers here are distinct and it's going to be from 0 through n, we can actually take the sum of all the numbers from 0 through n, which is what, the size of the array. And I think there's a way of doing this, isn't it? Like n times m plus 1 divided by 2. I think, let me see. If we do 3 times 4 divided by 2, that's 6. And 1 plus 2 is 3 plus 3 is 6. Okay, how about numbers from 1 through 5? 1 plus 2 is 3 plus 3 is 6 plus 4 is 10 plus 5 is 15. So if we do n 5 times 6 divided by 2 is 15. That'll give us the sum, right? Okay, that's going to give us the sum. I think what we need to do is, yo, Marvin, what up, dude? I think what I want to do here is I'm going to take the sum. The easiest thing to do, I think, is you take the sum and then subtract all the numbers that are there, and there's only going to be a single number that's missing. If all the numbers were present, then the sum minus all the numbers would equal 0. But if only one is missing, then the one that's missing is going to be the result of that at the end, if that makes any sense. So I think we can do let sum equals, let's see. Do we need to do a math.floor? I think we do. We can do math.floor of nums.length times nums.length plus 1 divided by 2. And then I think what we can do is you can say return nums.reduce, where we have our accumulator and our value. Our accumulator, oh nice, I'm alright. Had an interview with Motorola and got destroyed, but it's alright. Hey man, honestly, I have gone through like interviews myself, and I've gotten rejected a couple of times this year, and I wouldn't be where I am today. Like I wouldn't be in this YouTube channel or doing any of this content if it wasn't for those rejections. So there's a lot to gain from being rejected, and honestly, my mindset is no company can tell you what you're worth. So don't let like a name on your resume or the validity that you get from a company like define your self-worth. Because I have seen that good engineers are worth way more than whatever a company's going to tell them they're worth. So don't let that discourage you. If anything, let it encourage you, and just continue working hard, and I promise you'll get to whatever it is you want to get to. So our starting value will be our sum, right? And then all we need to do is do accumulator minus val, and that should give us the number. That should give us the sum. Or not the sum, but the missing number. 2 and 2. 2228. All right, cool. Yay, sweet. Yeah, Marvin, like I've definitely been there before, and in the beginning, like I'll be honest, like the first company I interviewed with after a long time of not interviewing with anyone was with Reddit in the beginning of this year. And in hindsight, I probably should have done Reddit later on during my journey. And I got rejected, and that one really hurt because I really wanted to work at Reddit. And then I did some other companies. I got some offers, but they wanted me to relocate, and I didn't want to relocate. So I decided to stay in my current company. And the company I work at was going through sort of a weird time, so it was sort of like an uncertain future. But more recently, things have gotten a lot better at the company I work at. And now I'm actually very happy to be there, and I'm being challenged, and I'm having a lot of fun. And I realized that it's not about, I used to think like my self-worth was defined by the name of a company on my resume, but now I realize that's not the case, because I work with some very good engineers. I've seen engineers that work at some of these other companies that are also, obviously you're going to have smart engineers everywhere. You're also going to have some engineers that are, you know, I don't want to say that it was luck or maybe by some other means, but some people, there's so many people at these companies that you're going to have a wide range of talent. So don't feel like if you don't make it to FANG or your top company, you're any less than any other engineer. I just thought I should throw that out there. Okay, So pretty cool solution, right? I think it actually fits. Yeah, we did this in like constant space, and yeah, linear runtime complexity. So what we did is we used this sum. I think this is like a summation formula where you do n times n plus 1 divided by 2. That will give you the sum of all numbers from 1 through n. And then we reduced nums where we set our initial value to the sum, and then we subtracted every single value inside of this array. And remember what I said in the beginning. We know that all the numbers are distinct. If every single number was present from 1 through n, then we'd end up with 0. But that's not the case. There's a single number missing, and the single number can be found by subtracting every number from the sum, and then we're left with the missing number. Hopefully that makes sense. I do like this question. It's pretty fun. So I'll add that one to my list. Let me remove some of these. Let's get to the next one. So move zeros. Yeah, this one's interesting because there's a really good way of doing it. There's like a crazy way of doing it. And then there's like a, well, I don't know if it's crazy, but let me see. Could you minimize the total number of operations done? I think there's a way that we can do it with 2 pointers, if I remember correctly. Let's see what we can do here. But it wants us to keeping the relative order of the array is the tough part, right? How would that look like? Because like the first way that I ever attempted to do this question was, let me do this so we have more room. Get my famous diamond going here. Is you essentially have 2 pointers, right? You have like a little, you have like this one. So let's let this square represent the index where the first non-zero number should go. Okay, so we start here. This is a 0 number, so we continue. Now we can swap. This is our first non-zero number, so let's swap it with the index where this is, right? So we can do 1, 0, and then we increment this pointer. Now we keep going here. 3 is another non-zero, so we do a swap. 3, 0, move this forward, move this forward. 12, another non-zero. We do a swap, and luckily for us in this example, we'd be done. But you can imagine a case where we have like an array of, I don't know, 1,000 indices, and we still have to like continue going along with this pointer here, checking every other index, even though we have no other non-zero numbers to swap. Give me 1 second, I'm gonna have some water. Right? So is there a way that we can do better? Let's see. Maybe with 2 pointers. That's what I'd like to try. So I'm going to give these guys some backgrounds here. Let's make this one that color. Let's make this one like, I don't know, this color. The hard thing is like keeping track. What is it that we want to find? Like at some point, if these indices cross each other, that's definitely going to help us minimize the amount of operations. One thing we can also do as well is we could count all the zeros in the array, and then we know as soon as we've done that amount of operations, like we should only do as many operations as there are zeros, and then we know that we've moved every 0. Could we solve this with 2 pointers? And how could that help us in this case? What other examples do we have? Oh, of course. Note that you must do this in place without making a copy of the array. It'd be kind of nice if like this pointer managed zeros, but then how do we, like what if every time we saw, oh, you know what? Maybe every time we see a 0, we decrement this one, maybe? Okay, so like we see a 0 here, so we decrement this. Then we come up here, we do the swap. But see, that wouldn't work because then, okay, we see another 0, but then we decrement this. but that doesn't really help. And why would I even decrement the back? What does that signify? Does it just signify like where? What if we started from here actually? What up? If I had something like this and I started from here, if I see a 0, we come down here, do a swap, see another 0, come down here. It's almost like maybe this pointer on the right will be where the last, like that's where the first 0 will be, right? Like after we move all the zeros, that's where the first 0 will be. And once we get to that point, we don't need to do anything else. Also, what if instead of moving all the non-zero numbers, we just moved the zeros? Could that be helpful? Like, okay, I see a 0 here. I use the swap method on this one. Yeah, no, that's the one I've always done too, but there's a more efficient way of doing it. And that's what the follow-up question asks, like, could you minimize the total number of operations done? Because imagine you just have something like, right? If you have something like this, then we have to wait to get all the way to the end before doing the swap. But maybe there's like a faster way of doing it, where I would just know that the back already has a 1 and just go from there. Could you minimize the total number of operations done? Give it an integer array nums, move all the zeros to the end of it while maintaining the relative order of the non-zero elements. You must do this without making a copy of the array. Let's think about this. Let's go back to the other example. 2-pointer method. But, you know, perhaps 2 pointers is not even the way of doing it, though. Like, this is just me theorizing about using 2 pointers, but it might not even be the right solution. And you want to minimize the amount of operations. It's almost like, what does it mean every single time we see a 0? Like, I know if I see a 0 here, I guess what we should do is, I almost want to draw like my end state. Let's do 0, 1, or 1, 3, 12, 0, 0. And okay, there you go. I know that every time I see a 0, I'm gonna just be like, how would I know to stop there? I see a 0, okay, I come up to the 1, I can swap it. Now I've just seen a 0, so do this. Come over here, I see another 0, okay, so do that, but then I get here, that's a 3. I could swap it with here, but that's a 12, and now it's over, so how would I know to even do anything in that case? I might not know how to do anything in that case. Minimize the amount of operations. I mean, wouldn't be, that wouldn't be just by doing it. Let me see something. Let's solve it the way that we know how to solve it. We can have something like let 0 index equals 0. For let I equals 0, I less than nums dot length I plus plus. If nums of I is greater than 0, then we can say nums of I, nums of 0 index equals nums of 0 index nums of I, 0 index plus plus, return nums. Let me just try this one out real quick. Let's see what we get just from doing that. 1 3 12 0 0. So yeah, this definitely, like, this way works, but I bet you, let me see the time complexity here. Ooh. What happened here? Oh, okay, if it's not equal to 0, because it can be negative too. If nums I is not equal to 0. Okay, nope, I don't want to contribute. Let's run the code for this one. That was a real, like, oversight right there. Submit this one. 24.71. You see, like, every non-zero number, but this is already, if it's not equal to 0, then we're going to swap it. Oh, see here, the 0 is already moved to the end, but I still needed to do this swap operation for every single one of these. So maybe instead of moving every non-zero number, what if we only move the zeros? But it could also be the case where it's a ton of zeros and just a 1, right? So there's definitely a faster way of doing this. Even though we get 97, I just want to see if it says, okay, it does say 2 pointers, so we're definitely, but see, like, are these the two, is this the 2 pointers? Because we are using 2 pointers, right? The I and 0 index are both, each one of those things are a pointer to an index. Minimize the total number of operations done. Like if we have this, right? Let's go back to Excalidraw. I think I lost Excalidraw. If we have this array right here, right? We know that we don't want to move anything because the 0 is already at the end. So what can we do that would actually let us know of that faster? Like, your category is wrong. Basic programming is not this. Yeah, no, I know. I would actually, if you know how to, like, the thing about Twitch is, I guess because it's like a gaming platform, they don't really have categories for LeetCode, or unless maybe I'm just not picking the right category. But yeah, if you know of a better category, or if you know the right category that I should put this on, please let me know, because at least on Streamlabs, it doesn't make it very clear. Like, I've tried coding, programming, JavaScript, LeetCode, and there just are no, I can't find the category for it. Is that why maybe I'm not getting a lot of views? Maybe. Could be because of that. But yeah, I'm open to suggestions, or like if you can point me in the right direction, that'd be awesome. I would really appreciate that. Yeah, this one is tricky right here, figuring out the optimal way. I mean, that's what the follow-ups are for, right? How do we get to the real nitty-gritty? It's mostly like in this one about figuring out that we already have the 0 at the end, so we shouldn't do anything else. if I had 2 pointers starting from the beginning and the end, and I knew at the end, because how also like how would we know that there aren't any other zeros in between? I guess like what if our left one looked for like the first look for the first 0, which would be here, and this one look for the first 1 non-zero, and if these are, if like start is greater than end, then we just break. Could we do something like that? Like if we go back to the previous one, previous example right here, if here I looked for the first 0, which is here, but see, then again we get to that point where it's like, how do I swap these? Where should I swap it? Because if I just swap, if I put 12 here, that's already wrong. Like this definitely needs to be 1. So what if I instead looked for, okay, maybe instead of find a 0, I say, okay, find the first non-zero, and here find the first 0. Okay. I'm not really sure what that does though. I mean, do I swap these at all? I wouldn't even be sure, like, how would I swap those, right? That's what makes it a little bit tricky. So I think maybe we'll save this one for like another day. At least that follow-up, I'm gonna need to know how to like keep track of that. I'll probably write it down in a note, like my notepad, to make sure to revisit this and try to get to that follow-up at some other point, because it's definitely worth getting to. Let's see if maybe we can do like one more contains duplicate. I think this one should be good. So given an integer array nums, return true if any value appears at least twice in the array. This one, there's like a couple of different times to do it, or ways of doing it. There's one way where you essentially just, you have like a dictionary, or let me see, 10 to the 5. You have an object literal or a dictionary that keeps the track of the frequencies. And as soon as you see a number that appears twice, you return false. Or rather, as soon as you see a number that appears twice, you return true. That's one way of doing it. So if we had something like const scene, and we can actually do, well, I can just say, we don't even need to keep the count. We can just say scene, and this can actually be a set. So for const n of nums, if scene dot has n, return true, else scene dot add n, then here return false. So let's go ahead and run our case for this. So this is really nice. This gives us like an unordered set. So it'll give us like constant time complexity for each one of these operations, like has and add, because of it's an unordered set underneath the hood, right? So what we do is we first check to see if our set contains the number we're on, else we add it, right? So do we have 1? No, so we add 1. Do we have 2? Nope, we add it. Do we have 3? Nope, we add it. Do we have 1? Yes, we do. Okay, 1, 2, 3, 4. Do you have 1? No, we add it. 2, no, we add it. 3, no, we add it. 4, no, we add it. We're at the end, we return false. That's one way of doing it. Another way of doing it is you literally create a set of the input and you compare it to the length of nums. So if the set and the size are the same, right, then that means that there are no unique ones. So we want, let's see, if it's not equal to, right, so we want return new set of nums dot size not equal to nums dot length, right? So if size.4 is not equal to 4, those like negations always trip me up. True, false, true, true, false, true. 56.83. Did we even go over the previous one? Did we even run the previous one? I don't know if we ran this one. Yeah, so both like really good solutions. I think this one's more helpful. I mean, I think if you can, the other one's a little more clever. This one's more helpful. And this pattern is a very common pattern where you're using something like a set to keep track of previously seen items and then doing something if you have seen them. So it's a very common pattern, especially for where we are right now in our journey with like the amount of easies that we've done. So I think I'll leave it off here since we're a little bit over the hour, and it'll give you all some good material to just like digest. We went over a lot of like very important questions. I feel like contains duplicate, move zeros, let's see, missing number. All these are like really good questions. So I think it's pretty good. I probably will add most of these to the list, if not like 3 out of the 4. So with that being said, really happy that you all were able to enjoy today's stream. Always good to see familiar faces like Hand Sanitizer and Marvin. Always a pleasure to be able to work with you all. So hopefully you all gained a little bit from this stream. I definitely need to keep track of some of these like move zeros. Let me actually, while I'm here on the air, look, I'm going to say like revisit move zeros for the follow-up. Just so you all know that we're actually going to revisit this. Let's say in here, follow-ups. That way we know to get to these during like weekly roundups or something like that. So with that being said, thank you all very much for watching today's stream. I definitely had a lot of fun with you all. Remember to subscribe to the channel if you haven't already. Follow me on Twitch. Leave some comments on the YouTube videos. I'll do my best to make sure I answer them in a timely manner. It's always good hearing from everyone. And I'm looking forward for us continuing our journey tomorrow, again with another live stream at 5 p.m. Eastern. And let's just have a good time coding. So again, thank you everyone.